In section 12.3, we're going to be subtracting rational numbers. In this video, we're going to be focusing on decimals. Let's remind ourselves how to subtract integers. Let's say, for example, I'm working with -5 minus -12. What we need to remember is when we subtract integers, we don't actually keep it a subtraction problem. We change all subtraction to addition. So the -5 is going to stay the -5. The minus becomes a plus, and then that -12 gets changed to +12. So what we're actually solving is -5 plus 12. Now I look at my numbers and I use the rules for addition. The signs are different, so I subtract the numbers, and I look to see what I have more of. Do I have more negatives or positives? I have more positives, so my answer is +7. Okay, so again, we change to addition. We take the opposite of the number we are subtracting by, and then we use the rules for addition. One more example, if I'm looking at -17 minus 8, first number stays the same. The minus becomes plus, and this 8 becomes -8. I'm adding numbers with the same sign, so I add, I get 25, and I keep the same sign. So what we want to do now is we want to add numbers with decimals, or subtract numbers with decimals. So let's do some examples. Please write the example down and pause the video. Try it out yourself to see if you do it right. Please do that for all three examples we have here. So -15.4 minus 12.81, we're dealing with negatives. It's going to become -15.4. The minus is going to become a plus, and that 12.81 is going to become -12.81, or 12 81/100ths. So I'm adding numbers with the same sign, so I'm going to end up adding those numbers and then just keeping the sign. So I'm going to keep the decimals lined up, 15.4, 12.81, or 12 81/100ths. I'm going to add them together. I'm going to put a 0 here. 0 and 1 is 1. 4 and 8 is 12. Carry the 1. We know the decimal goes straight down in our answer. 5 and 1 is 6, and 2 is 8. I have 28 and 21/100ths. Because I added numbers with the same sign, it's 28 and 21/100ths, and it's negative. So there is our first answer. For example B, let's try -5 and 13/100ths minus -21 and 9/10ths. Try it out yourself, come back and see how you did. Okay, so the first number stays the same, -5 and 13/100ths. Minus becomes plus, and -21 and 9/10ths becomes +21 and 9/10ths. I'm adding numbers with different signs, so I'm going to subtract, putting the bigger number on the top. Making sure to add the 0 so I have those place values covered. I can borrow from the 9. It's 10 minus 3 is 7. 8 minus 1 is 7. Decimal comes straight down. Have to borrow here again. 11 minus 5 is 7, and 1 minus 0 is 1. So I have 17 and 77/100ths. And when I look at my numbers now, I see that my positive number is bigger, or I have more positives than negatives. So my answer stays positive, 17 and 77/100ths. All right, looking at example 3, I have 3 numbers in here. Try this out yourself and see how you did. All right, so when I'm looking at this example, I notice that there really is only one subtraction. So that is the only one I'm going to change in this problem before I start solving. So if I rewrite it, I have 6. The minus becomes a plus, and 13.7 is going to become -13.7. Plus, I'm not going to change the next one because it already was an addition problem. You don't change addition problems, you only change subtraction problems. So it stays plus negative 1.2. I look at what I have here, and I know that I want to add my two negatives first because I add and keep the same sign. So I have 13.7 plus 1.2, and that gives me 9, my decimal, 14 and 9/10. And because I was adding numbers with the same sign, I add and keep the same sign. So my new problem now is 6 plus negative 14 and 9/10. Now I'm adding numbers with different signs, so I have to subtract. I take the bigger number, 14.9, and I subtract the 6, remembering that 6 is a whole number, so it's really 6.0. 9 minus 0 is 9. Decimal goes straight down. I'm going to borrow, it's still 14 minus 6, which is 8 and 9/10. So I have 8 and 9/10, and I look at my two numbers that I was adding, and I have more negatives than positives, so that means my answer is negative 8 and 9/10. We're now going to try to find distances between numbers on a number line. We've seen these problems before, but we've never really discussed them. So I want to find the difference between negative 2.8 and 4.7. When you picture it on a number line, it makes it a little bit easier. So if I have this number line, draw a real long one here, and I'm not going to be exact about this. I'm going to have my 0 in the middle. I'm going to go 1, 2, 3, 4, 5. So I know 4.7 is about right there. 1, 2, 3, 4. I know negative 2.8 is about here. Oops. It's not letting me put the dot, sorry. Okay, so negative 2.8 is about here. So if I'm finding the distance between these, what I'm actually doing is finding the entire distance between these 2 points. So to do that, you can't add because you're talking about a negative to 0 and a positive to 0. So what you actually have to do is subtract. So you're finding the difference between negative 2.8 and 4.7. It doesn't matter which number you put first for your subtraction problem. I'm going to put the 4.7 first. So I'm going to do 4.7 minus negative 2.8. I know that the 4.7 stays 4.7, minus becomes plus, and negative 2.8 becomes positive 2.8. So I'm really just adding 4.7 and 2.8. I line up my decimals. 7 and 8 is 15. I bring my decimal straight down. 4 and 1 is 5, and 2 is 7. And I added two positives, so the distance between those two numbers is 7.5 units. Now, if you would have put the negative 2.8 first, and you did negative 2.8 minus 4.7, you would have gotten negative 7.5 units. But because you're talking about a distance between 2 points, your answer needs to be positive because distance is a positive measure. Okay, try it out on your worksheet. Good luck.